Listed connectors recommended by the National Electrical Code. 1. Number 4 solid copper grounding electrode conductor to load center. Use a hubless concentric knockout connector, also known as an HKO connector, that is listed for direct burial, for example, the Ocal Unicon type ECJ. 2. Number 6 solid copper armored grounding electrode conductor to load center. Use a hubless concentric knockout connector, that is, an HKO connector, listed for direct burial with an armor clamp, for example, the Ocal Unicon type ECJ with armor clamp type WCJ. 3. Number 6 solid copper armored grounding electrode conductor to ground rod. Use a compression ground rod clamp with armor clamp, for example, the Burndy C6D with armor clamp type ARM6. Additional considerations: firstly, ensure that the armor is bonded at both ends using a listed connector, for example, Burndy YAHWO, or a bonding jumper, for example, Burndy BJB. Secondly, the ground rod should be driven to a depth of at least 8 feet in accordance with NEC 250.53. 8.1. Thirdly, if the armor cannot be buried due to the ground rod placement, consider using a non-metallic conduit or other approved method to protect the armor from damage. Fourthly, inspect the armor regularly for signs of corrosion and replace as necessary. Let's delve into these recommendations with a more detailed explanation. Grounding electrode conductors, or GECs, play a critical role in electrical safety. They provide a path for fault current to return to the source, allowing overcurrent protective devices like circuit breakers to trip and clear the fault. The National Electrical Code, or NEC, sets the standards for safe electrical installations, and it's essential to use listed connectors when making GEC connections. A listed connector means that it has been tested and certified by a recognized testing laboratory to meet specific safety standards. Using listed connectors ensures that the connection is reliable and safe. Now let's consider each of the connection scenarios in more detail. For a number 4 solid copper grounding electrode conductor to a load center, a hubless concentric knockout connector listed for direct burial is recommended. An example of this type of connector is the Ocal Unicon type ECJ. The term hubless concentric knockout, or HKO, refers to the design of the connector, which allows it to be installed in an enclosure without requiring a hub. This type of connector is typically used in situations where space is limited, or where a hub is not required. The fact that the connector is listed for direct burial is important because it means that it can be buried directly in the earth without being damaged by corrosion or other environmental factors. Now let's move on to the second scenario, a number 6 solid copper armored grounding electrode conductor to a load center. In this case, a hubless concentric knockout connector listed for direct burial with an armor clamp is recommended. An example of this type of connector is the Ocal Unicon type ECJ with armor clamp type WCJ. The armor clamp is used to secure the armor of the cable to the connector. This is important because it helps to prevent the armor from pulling away from the connector, which could create a safety hazard. The armor also needs to be effectively bonded to the load center enclosure. This can be achieved using listed connectors or bonding jumpers. Bonding ensures a low impedance path for fault current. The third scenario involves a number 6 solid copper armored grounding electrode conductor to a ground rod. Here, a compression ground rod clamp with armor clamp is recommended. An example of this type of connector is the Burndy C6D with armor clamp type ARM6. The compression ground rod clamp is used to secure the grounding electrode conductor to the ground rod. The armor clamp is used to secure the armor of the cable to the clamp. As with the connection to the load center, it's essential to ensure that the armor is properly bonded to the ground rod clamp. The NEC specifies that the ground rod must be driven to a depth of at least 8 feet. This is to ensure that the ground rod is in contact with the earth, which provides a path for fault current to return to the source. However, the NEC also recognizes that it may not always be possible to drive the ground rod to a depth of 8 feet due to obstructions or other factors. In these cases, the NEC allows for the ground rod to be buried horizontally, provided that it is buried at a depth of at least 30 inches. Another important consideration when installing a grounding electrode conductor is to protect it from physical damage. The NEC requires that grounding electrode conductors be protected from physical damage by being installed in conduit or other approved means. This is to prevent the grounding electrode conductor from being damaged by accidental contact with tools, equipment, or other objects. It's also important to inspect the grounding electrode conductor regularly for signs of corrosion or damage. If the grounding electrode conductor is corroded or damaged, it should be replaced immediately. Corrosion can significantly reduce the effectiveness of the grounding electrode conductor, which could create a safety hazard. In addition to the specific recommendations discussed above, there are a few other general considerations that should be kept in mind when installing grounding electrode conductors. Firstly, always follow the manufacturer's instructions when installing connectors and clamps. This will help to ensure that the connection is made correctly and safely. Secondly, use the correct tools for the job. Using the wrong tools can damage the connectors or clamps, which could create a safety hazard. Thirdly, make sure that all connections are tight. Loose connections can create resistance, which can reduce the effectiveness of the grounding electrode conductor. Fourthly, keep the grounding electrode conductor as short and straight as possible. This will help to minimize the impedance of the grounding electrode conductor. The shorter and straighter the conductor, the lower the impedance and the more effective it will be in carrying fault current. Fifthly, avoid making sharp bends in the grounding electrode conductor. Sharp bends can increase the impedance of the grounding electrode conductor. Sixthly, protect the grounding electrode conductor from physical damage. As mentioned earlier, the NEC requires that grounding electrode conductors be protected from physical damage. Seventhly, inspect the grounding electrode conductor regularly for signs of corrosion or damage. Corrosion and damage can significantly reduce the effectiveness of the grounding electrode conductor. Eighthly, test the grounding electrode conductor to ensure that it is working properly. This can be done using a ground resistance meter. A ground resistance meter measures the resistance between the grounding electrode and the earth. The lower the resistance, the better the grounding electrode is working. Finally, it is important to note that the NEC is a complex document, and it is essential to consult with a qualified electrician if you have any questions about grounding electrode conductors or other electrical topics. A qualified electrician will be able to provide you with expert advice and guidance on how to safely and effectively install grounding electrode conductors. By following these recommendations and considerations, you can help to ensure that your electrical system is safe and reliable. Remember that grounding electrode conductors are a critical part of any electrical system, and it's essential to install them correctly. Let's expand further on the importance of each recommendation. The selection of listed connectors is paramount. The NEC mandates the use of connectors that have been evaluated and listed by a recognized testing laboratory. This listing signifies that the connector meets stringent safety and performance standards. These standards cover aspects like material quality, mechanical strength, and electrical conductivity. Using non-listed connectors can compromise the integrity of the grounding system, potentially leading to increased resistance, corrosion, and ultimately a failure to provide an effective path for fault current. This can put people and property at risk. Hubless concentric knockout connectors, or HKO connectors, are specifically designed for use in electrical enclosures. Their hubless design allows for easy installation in tight spaces, and the concentric knockout feature provides a clean and secure connection point. When selecting an HKO connector for a grounding electrode conductor, it's important to choose one that is specifically listed for direct burial. Direct burial connectors are constructed with materials that are resistant to corrosion and degradation from soil and moisture. Using a non-direct burial connector in a direct burial application can lead to premature failure of the connection, compromising the integrity of the grounding system. The armor clamp is a critical component when using armored grounding electrode conductors. The armor clamp securely grips the metal armor of the cable, providing a reliable electrical connection between the armor and the connector. This is important for two reasons. Firstly, it ensures that the armor is properly grounded, which helps to protect against electrical shock. Secondly, it provides a low impedance path for fault current, which helps to trip over current protective devices quickly and effectively. When selecting an armor clamp, it's important to choose one that is specifically designed for the type of armor being used. There are different types of armor clamps available for different types of armored cables. Using the wrong type of armor clamp can damage the armor or create a loose connection. Compression ground rod clamps are used to connect the grounding electrode conductor to the ground rod. These clamps are designed to provide a secure and reliable connection that can withstand the stresses of being buried in the earth. When selecting a compression ground rod clamp, it's important to choose one that is made of corrosion-resistant materials. Ground rods are typically made of copper or copper-clad steel, so the clamp should also be made of a compatible material to prevent galvanic corrosion. It's also important to choose a clamp that is sized appropriately for the grounding electrode conductor and the ground rod. The NEC requires that ground rods be driven to a depth of at least 8 feet. This is to ensure that the ground rod is in contact with the earth's moisture, which helps to improve its conductivity. In areas with dry soil conditions, it may be necessary to drive the ground rod deeper than 8 feet to reach moisture. If it is not possible to drive the ground rod to a depth of 8 feet due to obstructions, the NEC allows for the use of multiple ground rods. When using multiple ground rods, they must be spaced at least 6 feet apart. This spacing is necessary to prevent the ground rods from interfering with each other's effectiveness. Protecting the grounding electrode conductor from physical damage is also crucial. The NEC requires that grounding electrode conductors be protected from physical damage by being installed in conduit or other approved means. This is to prevent the grounding electrode conductor from being damaged by accidental contact with tools, equipment, or other objects. If the grounding electrode conductor is damaged, it may not be able to carry fault current effectively, which could create a safety hazard. Regular inspection of the grounding electrode conductor is also important. The grounding electrode conductor should be inspected regularly for signs of corrosion or damage. Corrosion can significantly reduce the effectiveness of the grounding electrode conductor, which could create a safety hazard. If the grounding electrode conductor is corroded or damaged, it should be replaced immediately. Proper bonding of the armor is a critical safety measure. The armor of armored cables provides a degree of mechanical protection to the conductors inside, but it's crucial that this armor is also properly bonded to the electrical system's grounding network. Bonding ensures that the armor is at the same electrical potential as other grounded metal parts, minimizing the risk of electric shock if the armor becomes energized due to a fault. This bonding is typically achieved by using listed bonding connectors or bonding jumpers that create a reliable electrical connection between the armor and the grounding system. The 8-foot ground rod depth is mandated by the NEC to ensure effective contact with the earth. Driving a ground rod to a depth of at least 8 feet is a fundamental requirement of the NEC. This depth is specified to ensure that the ground rod makes reliable contact with the earth, providing a low resistance path for fault current to dissipate into the ground. The earth's conductivity varies depending on factors like moisture content and soil composition, but the 8-foot depth generally provides a sufficient level of contact to ensure effective grounding. Now let's discuss non-metallic conduit. In situations where burying the entire length of the armored cable is impractical due to ground rod placement or soil conditions, using non-metallic conduit offers a viable solution. Non-metallic conduit, such as PVC or rigid non-metallic conduit, is resistant to corrosion and provides physical protection to the grounding electrode conductor. By encasing the GEC in conduit, you can protect it from moisture, chemicals, and physical damage, extending its lifespan and ensuring the continued integrity of the grounding system. It is essential to select conduit and fittings that are suitable for direct burial and listed for the intended application. Finally, always perform regular inspections of your ground connections. Regular inspections are vital for maintaining the integrity of the grounding system. Over time, connections can loosen, corrode, or become damaged due to environmental factors or physical stress. Regular inspections allow you to identify and address potential problems before they escalate into serious safety hazards. During inspections, check for signs of corrosion, loose connections, or physical damage to the grounding electrode conductor, connectors, and ground rod. Tighten any loose connections, replace corroded or damaged components, and ensure that the grounding electrode conductor is properly supported and protected. By implementing a proactive inspection and maintenance program, you can ensure that your grounding system remains effective and reliable, providing continuous protection against electrical hazards. The overarching goal is to create and maintain a safe and effective grounding system that protects people and property from electrical hazards. By adhering to the NEC guidelines, using listed components, and implementing proper installation and maintenance practices, you can achieve this goal and ensure the reliable operation of your electrical system.